morning everyone. In this session, we discuss about reference electrode, types of reference electrode and construction and working of calomel electrode. In order to measure the potential of any single electrode, it should be coupled with other electrode of known potential to form a galvanic cell. The EMF of the galvanic cell is measured by using voltmeter. By knowing the potential of one electrode and EMF of the cell, we can easily measure the potential of other electrode from the equation E cell is equal to electrode potential of cathode minus electrode potential of anode. By using this equation, we can easily calculate by knowing the potential of any one of this electrode as well as the EMF of the cell, we can calculate the potential of any single electrode. So hence, to measure the potential of any single electrode, we must know the potential values of other electrode. So therefore, definition for reference electrode is nothing but an electrode of known potential, an electrode of known potential with respect to which the potential of other electrode can be measured is called as a reference electrode. So that means an electrode of known potential with respect to which the potential of other electrode can be measured is called as a reference electrode. There are two types of reference electrode. They are primary reference electrode and a secondary reference electrode. There are two types of reference electrodes. They are primary reference electrode and a secondary reference electrode. The best example for primary reference electrode is standard hydrogen electrode, or it is abbreviated by SHE. SHE means standard hydrogen electrode. In PU classes you already studied the construction and working of standard hydrogen electrode. So it is a gas electrode. It consists of inert metal like platinum. It is dipped in a 1 molar hydrogen solution, and hydrogen gas of 1 atmosphere is continuously bubbled over it. So generally it is represented as, she is represented as platinum foil which is in contact with HCl solution, and hydrogen gas should be bubbled. Hydrogen gas at 1 atmosphere is continuously bubbled over it, and HCl of 1 molar. Observe that this is the general representation of standard hydrogen electrode. Platinum, hydrogen gas. So pressure should be 1 atmosphere. Then HCl, its concentration is 1 molar. This single vertical line represents the phase boundary. So what are the drawbacks of She? Why we are using secondary reference electrode nowadays? The reason for that, it is primary reference electrode has many drawbacks. The drawbacks are, it is a gas electrode. Hydrogen electrode is a gas electrode, and pressure of hydrogen has to be maintained at 1 atmosphere, which is very difficult under normal laboratory conditions. Under common laboratories, it is very difficult to maintain the pressure at 1 atmosphere. So platinum metal which is used in the electrode is easily poisoned by any impurities present in the system. Oxidizing agent like nitrates, chlorides, hydrogen sulfide easily poison platinum metal. So another drawback is it cannot be used if solution contains metal ions like silver ions, that is Ag plus ions, since the metals may be reduced by hydrogen. So therefore, to overcome these drawbacks, nowadays we are using secondary reference electrode to measure the potential of other electrodes. Therefore, instead of She, secondary reference electrodes are commonly used in laboratories to measure the potential of other electrodes. Then what are secondary electrodes? An electrode whose potential is measured with respect to She. That means First, these electrodes are coupled with a sheet, then the potential of these electrodes are measured, then that can be used as a reference electrode for measuring the potential of other electrodes are known as secondary reference electrode. Reference electrode, there are two examples for this type of secondary reference electrode, and both are metal insoluble salt electrodes. They are calomel electrode and silver chloride electrode. These two are example for secondary reference electrode. What are the advantages of secondary reference electrode? These electrodes are easy to set up and operate, and these electrodes are not poisoned by oxidizing agents, and potential values of these electrode do not vary too much variation of temperature. These are the advantages of secondary reference electrode. Let us discuss the construction and working of calomel electrode. For construction and working of calomel electrode, observe this diagram. So, this diagram represents the calomel electrode. So, observe this diagram. According to this diagram, calomel electrode consists of a glass tube. Liquid mercury is placed at the bottom. It is covered by a paste of mercury and mercurous chloride. Observe that Hg2Cl2 is known as mercurous chloride. Commercially, it is known as a calomel. So, therefore, this electrode is known as a calomel electrode. What is the commercial name of this mercurous chloride? Commercially, it is known as a calomel electrode. So, that is why this electrode is known as a calomel electrode. Further, it is in contact with KCl solution. Once again, I am repeating, calomel electrode consists of a glass tube having liquid mercury at its bottom, and it is covered by a paste of mercury and mercurous chloride. Further, it is in contact with KCl solution. A platinum wire is dipped in a or placed in a mercury. The role of this platinum wire is it is used to measure the potential of this electrode and also for electrical contact for other electrode. That means the role of this platinum electrode is it is used to measure the potential of this calomel electrode, and it is used to couple this electrode with other electrode, and this is taken in a outer tube. At the bottom of the outer tube there is a porous disc. This porous disc acts as a salt bridge. Is it clear the construction of calomel electrode? Calomel electrode consists of a glass tube having liquid mercury at its bottom. It is covered by a paste of mercury and mercurous chloride. Further, it is in contact with KCl solution. A platinum wire is dipped in a mercury, and it is used to measure the potential of this electrode, and it is also used to couple this electrode with other electrode. Then this one is taken in a outer tube. So, at the bottom of the outer tube there is a porous disc. This porous disc acts as a salt bridge. Next, learn that depending upon the coupled electrode, that means if the coupled electrode potential is less than the electrode potential of this electrode, in that case this electrode acts as a cathode and the coupled electrode acts as a anode. Or the coupled electrode potential is greater than calomel electrode, in that case this electrode acts as a anode and the coupled electrode acts as a cathode. That means calomel electrode can behave as an anode as well as cathode depending upon the nature of the copper electrode. If this electrode acts as an anode, so if the calomel electrode acts as an anode, we already know that at anode always oxidation reaction takes place. Then what is the oxidation reaction when this calomel electrode acts as a anode? The oxidation reaction is, observe that what is the metal present in this electrode? Observe that mercury is an example for a liquid metal. So, therefore, the metal in that electrode is mercury. Mercury is represented by Hg. This mercury easily loses 2 electrons, then it is converted to mercurous ion. Observe that mercurous ion is represented by Hg2 plus excuse me, with the liberation of 2 electrons. Observe that what is the first oxidation reaction? The metal present in this electrode is a mercury. Mercury easily loses 2 electron, then it is changes to mercurous ion. This mercurous ion is highly reactive, so therefore this mercurous ion reacts with anion of KCl. Observe that what is the anion of KCl? So K is the cation and Cl is the anion. So this mercurous ion is highly reactive, so therefore it reacts with the anion of the KCl, that means Cl minus, it is converted to Hg2Cl2, that is mercurous chloride. Then what is the net reaction when the calomel electrode acts as an anode? Means we have to add these two equations. Add these two equations, what is the Hg plus, observe that this Hg2 2 plus form reacts with the chloride ions, it is converted into mercurous chloride, so therefore there is no free mercurous ion. So therefore Hg plus, observe that we have to balance these two equations individually. So balance the first equation. So observe that here Hg is 2, so therefore we have to write 2 here. Next, in the second equation chloride is 2, so therefore we have to write 2 here. So then add these two equations, we get 2Hg plus 2Cl minus gives Hg2Cl2 plus 2 electron. This is the net reaction takes place when this electrode acts as a anode. So what is the anode reaction when the calomel electrode acts as a anode? Observe that the net anode reaction is 2Hg reacts with 2Cl minus gives Hg2Cl2 with the liberation of electron. This confirms the oxidation reaction. Oxidation reaction means there should be a liberation of electrons. So what is the first reaction? Mercury easily loses 2 electrons, then it becomes mercurous ion. This mercurous ion further reacts with 2 moles of chloride ions, we get mercurous chloride. So therefore net reaction is 2Hg plus 2Cl minus gives mercurous chloride with the liberation of 2 electrons. For example, if the couple electrode potential is lesser than the calomel electrode, in that case this calomel electrode behaves as cathode. Then cathode means there should be a reduction reaction. Then how to write the electrode reaction? Observe that here there is no metal ions. So observe that first mercury, then it is in contact with mercury and mercurous chloride. So therefore first reaction is the salt, that is mercurous chloride HgCl2 is ionizes as Hg2 plus Cl minus. Observe that when this electrode acts as a cathode, the salt which is present in the electrode, that is mercurous chloride, ionizes as Hg2 2 plus Cl minus. Then this Hg2 2 plus, that is metal ions, gains electrons from outer circuit, then it is reduced to mercury. Balance the equation. Observe that in first equation chlorine is 2, so therefore put 2 here. Next Hg2 2 plus gains 2 electrons, then it is reduced to mercury. Here mercury is 2, so therefore 2Hg. What is the net reduction reaction? Add these two equations, that is Hg2Cl2 plus 2 electron gives 2Hg plus 2Cl minus. This is the net reaction when this electrode acts as a cathode. So observe that cathode reaction means there should be a reduction reaction takes place. So therefore reduction reaction is represented like this. First the mercurous chloride ionizes as mercurous ion and chloride ions. This mercurous ions gains electron from anode, then it is reduced to mercury. So therefore net reaction is Hg2Cl2 plus 2 electron gives 2Hg plus Cl minus. Reduction reaction means there should be a gaining of electrons. So, therefore, 2 electrons. Next, what is the net reversible reaction that occurs at calomel electrode? These two reactions are reversible. So, therefore, net reaction that taking place in a calomel electrode is represented like this: Hg2Cl2, that is mercurous chloride plus 2 electrons, reversible sign, 2Hg plus 2Cl minus. Observe that this is the net reversible reaction takes place in a calomel electrode. Observe that mercurous chloride is a solid and mercury is a liquid. So, therefore, only variable here is chloride ions. So, therefore, this calomel electrode is reversible with respect to chloride ions. Calomel electrode is reversible with respect to chloride ions. Then write the Nernst expression for this equation. Write the Nernst equation for forward reaction. So, recall the Nernst equation. What is the Nernst equation? E cell is equal to, here it is E calomel electrode. Calomel electrode is abbreviated by Ce. Ce represent the calomel electrode. Electrode potential of calomel electrode is equal to standard electrode potential of calomel electrode plus 2.303 RT divided by NF log base 10 of, here concentration of reactants divided by concentration of products. Observe that here the reactants is mercurous chloride. For mercurous chloride, the concentration is always taken as 1. So, therefore, here it becomes 1 divided by the product of molar concentration of products. Here the product is, this one is a liquid and this one is a aqueous solution. So, observe that here the concentration of liquid is also considered as 1. So, therefore, it become Cl minus. Okay, observe that here 2 moles are present. So, therefore, number of moles are raised as a power. So, therefore, this is the Nernst equation to calculate the potential of calomel electrode. That is, E calomel electrode is equal to standard electrode potential of calomel electrode plus 2.303 RT divided by NF log base 10 of 1 divided by concentration of chloride ions to the power 2. Observe that the concentration of chloride and the electrode potential of calomel are inversely proportional. This gives the information that as the concentration of chloride ion increases, the electrode potential of calomel electrode decreases. So, therefore, the potential values of calomel electrode depends upon the concentration of a chloride ions or concentration of a KCl solution. So, the calomel values depends on the concentration of KCl solution. For example, if the concentration of KCl solution taken is 0.1 normal, it is known as a decinormal. In that case, if the KCl solution taken, the concentration of KCl solution filled in this electrode is 0.1 normal, then that electrode is known as a decinormal calomel electrode. So, if we couple this decinormal calomel electrode with a standard electrode potential and if we measure the potential, then we get the value as 0.335 volt. Observe that generally the potential is expressed in volt. So, therefore, what is the decinormal calomel electrode value? Its value is 0.335 volt. So, instead of decinormal, if we use a normal KCl solution, so that means this electrode is filled with one normal KCl solution, then it is known as a normal calomel electrode. In that case, its value is 0.2810 volt. If we use one normal KCl solution in a calomel electrode, then it is known as a normal calomel electrode, then its value is 0.2810. If we use saturated KCl solution, so that means if this electrode is filled with a saturated KCl solution. In that case, this calomel electrode is known as a saturated calomel electrode and its value is 0.2422 volt. Observe that depending upon the concentration of the KCl solution filled in the calomel electrode, so its value changes. So according to this Nernst equation, as the concentration of chloride ions increases means its electrode potential decreases. Observe these values. For saturated calomel electrode, the electrode potential value is 0.2422. For normal KCl solution, the potential value is 0.2810. For deci-normal KCl solution, the potential of calomel electrode is 0.3335 volt. This is the explanation for construction and working of calomel electrode. In this session, we discussed about reference electrode, types of reference electrode, definition for primary reference electrode and drawbacks of She, and definition for secondary electrodes and example for secondary reference electrode, and construction and working of calomel electrode.